the Spring Boot project, and then we'll configure MySQL database in our Spring Boot application. Next, we'll create a product JP entity. Next, we'll create product repository interface, and then we create a JPQL and native SQL queries for search REST API. Next, we'll create a service layer, and then we'll build search REST API, and then finally we'll test it using Postman client. Well, I'm going to cover each step in a separate lecture. Alright, so first let's go ahead and let's create a Spring Boot project in this lecture. Well, let's head over to your favorite browser. So I'm in a Chrome browser. Just type start.spring.io. So this will bring up Spring Initializer website. Well, Spring Initializer is basically a website or tool which you can use to quickly create Spring-based application. Alright, now let's go ahead and let's fill up all these project information over here. So here we have two types of projects. Project and Kaggle project. So let's keep my main project as selected. And here three JVM languages like Java, Kotlin, Ruby. So let's keep Java as selected. And let's keep the Spring Boot version, that is 2.6.6. So this is basically a stable and latest version of Spring Boot. And Spring Boot team also recommend to use this 2.6.6 version right now. Okay, but you may see this Spring Boot version different whenever you use this video. Alright, so make sure that you choose the Spring Boot version that is recommended by Spring Boot team. Alright, great. Now let's go ahead and let's fill up project metadata over here. So here I'm going to give group ID as net.java guides, and then artifact ID. Let's give Spring Boot search REST API and name. So name is same as artifact. So let's keep as it is. And description, let's give Spring Boot search REST API with MySQL database. Alright, perfect. Let's give package name as net.javaguides.springboot. Alright, perfect. Let's keep packaging as a jar. Next, Java version. So I'm going to keep Java 11 as selected, but you can go ahead and use Java 8, 11, 17, 18 as per the JDK installation in your machine. Alright, now let's go to the dependency section over here. Click on add dependency. So we're going to use web dependency, that is Spring Web dependency, to develop the REST APIs. So go ahead and select Spring Web dependency. Apart from that, we're going to use Spring Data JPA dependency. Well, we're going to build a repository here or a DAO here. So we're going to choose Spring Data JPA, and Spring Data JPA internally uses Hibernate as a JPA provider. Alright, and basically we use Spring Data JPA to reduce a lot of boilerplate code which is required to develop the DAO layer or a repository layer. Well, let's select Spring Data JPA, and I'm going to use MySQL database. For that, I'm going to use MySQL JDBC driver. Next, we're going to use Lombok dependency. So Lombok dependency or Lombok library is basically helps us to reduce the boilerplate code. Okay, in a project we'll see how we can use Lombok library annotations to reduce the boilerplate code. Okay, so let's choose Lombok dependency. Alright, so these are the dependencies that we're going to use in our Spring Boot application. Well, at the bottom you can see a couple of options like generate, explore, share. Well, if you want to explore the Spring Boot application, you can go ahead and click on explore, and you can explore the project structure and all the files. Alright, so if you can open POM.xml file, you can able to see all the dependencies that you have selected is added to the POM.xml file. Alright, perfect. Just close it and go ahead and click on generate button to generate the Spring Boot application. Well, you can see Spring Boot search REST API.zip. So Spring Boot application is generated as a zip file and it is downloaded in a file system. Let's go ahead and let's open this zip file in a folder. Alright, now let's extract this zip file. Well, once we extract the zip file, let's go and let's open the IntelliJ IDEA. Alright, so in IntelliJ IDEA you can see a couple of options like new project, open, get from, VCS. So now open the existing project in IntelliJ IDEA. So go ahead and click on open over here and just go ahead and choose the project. So go to downloads folder and choose Spring Boot REST API project. Well, IntelliJ IDEA will download all the dependencies and it will set up the Spring Boot application. Now you can able to see our Spring Boot application is successfully imported in the IntelliJ IDEA. Alright, perfect. Now what we'll do, we'll create a project structure for our Spring Boot application. We'll go to the main package over here, right click, new and choose package. Let's give package name as entity and hit enter. So let's go and let's create one more package. Let's call it as controller. Within the controller we keep all the Spring MVC controllers. Let's go and let's create one more package. Let's call it as repository. Within a repository package, we're going to keep all the Spring Data JPA repositories. So let's go and let's create one more package and let's call it as service. Within a service package, we keep all the services. Okay, service classes and interface. Well, to keep it simple, we have created these four packages as of now. If required, we'll create later. Now, what we're going to do is we're going to configure MySQL database in our Spring Boot application. So go to the resources folder. Within resources folder, we have application.properties file. Well, within the application.properties file, we're going to configure MySQL database so that our Spring Boot application can able to connect to the MySQL database. Well, before that, first we'll create the database. Well, let's head over to the MySQL workbench. So I'm going to use MySQL workbench to create the database and interact with the MySQL server. Well, MySQL workbench is one of the MySQL client that we can use to interact with the MySQL server. Well, here I'm going to quickly create the database. So just type the SQL statement create database followed by database name. So let me give database name as search API, something like that. So you can give any database name that you want. But for this functionality, I mean, we are developing search REST API. Hence, I am going to give database name something like search underscore API. Alright. So let's go and let's execute this SQL statement, and this will create the database. Let's refresh the schemas, and here you can able to see search underscore API database is created. Alright, perfect. Now we are going to configure this database in our Spring Boot application. Alright, perfect. Well, let's type the property spring dot data source dot URL, and let's provide a JDBC URL. To connect to the MySQL database. So just type the value as JDBC colon MySQL colon localhost. So we are going to connect our Spring Boot application to localhost database. That's why localhost over here, followed by 3306 is the port of the MySQL database. And then let's configure the database. Let's give database name as search underscore API. Right? Next, let's configure database username and password. Let's type the property spring dot data source dot username equal to root. Similarly, let's configure database password. Let's type the property spring dot data source dot password equal to whatever the password you have given to the MySQL database that you can give here. But make sure that you will configure the database username and password as per the MySQL installation on your machine. Alright, perfect. Well, next we need to configure Hibernate Dilate. Well, let's go and let's type the property spring.jpa.properties.hibernate.dilate, and the value is org.hibernate.dilate.mysql5 dilate. Okay, so we're gonna use latest MySQL dilate over here. So I'm gonna remove this and I will add MySQL 8 dilate. Okay, so this is the latest dilate, Hibernate dilate for MySQL database. Okay, now we have configured Hibernate Dilate for MySQL database vendor. Okay, well basically Hibernate uses this dilate to create the SQL statements based on the database. In our case, we are using MySQL database. So Hibernate will use this dilate to generate the SQL statements with respect to MySQL database vendor. Now let's go ahead and let's configure a few more Hibernate useful properties. For example, spring.jpa.hibernate DDL auto property. Well, this property is pretty useful. So this property will tell Hibernate that generate the database tables based on the JP entities that we have, created in our Spring Boot application. Okay, and make sure that you provide update as a value. Next, we have spring.jpa.properties.hibernate.show underscore SQL equal to true. So this property tells that Hibernate need to show the SQL statements in a console. Okay, and next spring.jpa.properties.hibernate format underscore SQL equal to true. So this property will tell Hibernate that whatever the SQL statement that Hibernate show in a console should be well formatted. Alright, so these are the few useful Hibernate properties that we can use in our Spring Boot application. Now we have configured MySQL database in our Spring Boot application. So let's go ahead and let's run our Spring Boot application and we'll verify that whether our Spring Boot application will be able to connect to the MySQL database or not. Okay, let's go to main entry point of the Spring Boot application and let's go ahead and let's run the Spring Boot application. Alright, and there we go. We can able to see here there is no error or exception in the console. It means that our Spring Boot application is successfully connected with the MySQL database, and you can able to see Hibernate uses org.hibernate.dilate.mysql8 dilate. Alright, so it means that our Spring Boot application is successfully connected with the MySQL database. Next, we will create a JPA entity. So just minimize this and go to entity package. Right click on the entity package, new, and then choose Java class. And let's go ahead and let's give entity class name as product. Hit enter. Now let's go and let's define the properties for this product class. Let's say private long ID and then private string stock keeping unit and then private string name. So this is going to be a product name and then string product description. Alright, and then private boolean active. Okay, whether the product is active or not, and then private string product image URL, right? So let's view image URL over here. Next, private local date time. Let's say date created. So this is the product date created, and then private local date time, date updated. Okay, perfect. So these are the fields, for this product class. Next, we're going to use Lombo connotations to automatically generate the getter setter methods and constructors for this product class. Well, let's use add generate annotation to generate a getter methods for these fields, and let's use add setter annotation to generate setter methods for these fields, and we're going to use add no argument construct over here. Next, we're going to use all argument construct. Okay, so these are the pretty useful Lombo connotations to automatically generate getter setter methods and constructors. Alright, perfect. Now we have created product class. Now let's make this product class as a JPA entity by using JPA annotations. Well, let's use add entity annotation. So this add entity annotation will basically mark this class as a JPA entity. Next, we will use add table annotation to configure table details for this product entity. So we're gonna give name to the table, something like products. Next, we need to configure a primary key for the table. For that, we're gonna use a JPA annotation that is add ID annotation. Next, we need to provide a primary key generation strategy. For that, we're gonna use add generated value annotation, and we will configure primary key generation strategy. So let's use a generation type dot identity as a primary key generation strategy. Okay, so this will basically use a database auto increment property to auto increment the primary key. Okay, next here we're gonna use Hibernate provided few of the useful annotations to automatically populate the values for these properties. So here, let's say creation timestamp. Okay, so this one creation timestamp from org.hibernate.annotations package. So this annotation is pretty useful. Whenever we save the product, Hibernate will automatically assign the value for this property. Okay, let's use this annotation. Next, we're going to use one more Hibernate annotation for this field, that is add update timestamp annotation from org.hibernate.annotations package. Okay, so these Hibernate annotations are pretty useful because these annotations will automatically populate the values for these fields. Okay, great. Now we have created product JPA entity. Well, let's run our Spring Boot application and let's verify whether Hibernate will create this product table in a MySQL database or not. So let me go to the main entry point class and from here I'm going to run Spring Boot application. Okay, and you can able to see in the console Hibernate generated SQL statement. Okay, so this is a DDL SQL statement to create the products table. Now let's verify from the MySQL workbench. So go to MySQL workbench and just refresh the schemas and go to search underscore ABI schema, and there you go, products table is successfully created. Okay, now we have successfully created product JP entity. Next, we will create Spring Data JP repository for product JP entity. So go to repository package, right click new and then choose Java class and then choose interface, and let's use Spring Data JP repository name as product repository. Hit enter. Well, this interface should extend JPA repository interface from Spring Data JPA library. Okay, and if you can see here, JPA repository is basically a generic interface. We have to pass two parameters. All right, so let's choose JPA repository interface and then pass first parameter as a product, second parameter as type of the primary key, that is long. Okay, that's it. Well, now we have created a product repository interface that extends JPA repository interface from Spring Data JPA. Okay, if you can deep dive into JPA repository interface, it will provide a lot of methods like find all by ID, okay, save and flush, delete all by ID, delete all in batch, okay, get by ID. All right, so JPA repository interface will provide all these methods. Apart from that, JPA repository interface internally extends paging and sorting repository interface. So paging and sorting repository interface will provide these methods to perform pagination and sorting. Okay, and paging and sorting repository interface internally extends CRUD repository interface, and CRUD repository interface will provide all these methods to perform different operations, that is database operations with respect to the product entity. Okay, for example, save all, find by ID, exist by ID, find all. All right, it means that Spring Data JPA will provide all these methods to perform all these kind of operations with respect to MySQL database for product JPA entity. Okay, so let's go back to our product repository interface now. Okay, and one more important point here is we don't have to annotate this product repository interface with add repository annotation, because Spring Data JPA internally provides add repository annotation. All right, and we don't have to again annotate this interface with add repository annotation. All right, perfect. Well, within a product repository interface, we are going to create a query method that returns the list of products based on the search criteria. Okay, so within a product repository interface, we are going to create a query method. So let's go ahead and let's view a query method return type as a list of products. Let's create a list of my product and let's give a query method name something like search products, and we are going to pass the query as a search criteria. Well, we are going to use JPQL query to search or filter the products. So here, in order to define the JPQL query, we have to use add query annotation from Spring Data JPA. And within this add query annotation, we are going to pass a JPQL query, right? So here is the JPQL query, select P is basically alias from product. So in case of JPQL query, we have to provide a class name and field name, right? We don't have to provide table name and columns, right? So here we are basically creating JPQL query, so we have to use class name here and give the alias P. All right, and just have a where condition over here, where, and then we're going to basically filter the products by name and description, right? So here what I'm going to do is we're going to say P dot name. All right, and we're going to use like condition here. After that, we're going to use concat operation or function, and we're going to pass three parameters. First one is percent, and then colon query, and then third is percentage. All right, perfect. So here we are using concat function to concatenate these three parameters. Okay, perfect. Now we have added search or filter criteria for name. Similarly, let's go and let's add this condition for product description as well. So here what I'm going to do is I'm going to say P dot description like, and then concat, and then similarly pass three parameters, that is percentage, comma, and then colon query, and then within a single quote percentage. All right, perfect. Well, within this JPQL query, we are using named parameter to pass the value. Okay, so this colon query is basically a named parameter, and Spring Data GPU will dynamically bind the value that we pass to this colon query. Okay, now we have written a JPQL query to filter products by name and description. Okay, pretty simple. Well, let me recap what we have done. We have created a search products query method, and we have passed search query as a parameter, and then we have annotated this query method with add query annotation, and then we have passed this JPQL query. Well, the JPQL query is select P from product where name like this, or so here should be, or description like this. Okay, so we are going to basically filter or search a list of products by name or description. Okay, so this is the JPQL query to search or filter a list of products by name or description. Well, we can also use native SQL query to search list of products by name or description. Okay, so here we have used JPQL query, but we can also use native SQL query as well. So let me show you how we can use native SQL query. So let me quickly copy this and let me paste it over here, and let me change the query method name. Let's say search products SQL, and let's replace this JPQL query with native SQL query. So instead of using class name, we have to use table name. The table name is products. Okay, and here one more changes. Instead of using alias, we have to use star over here. All right, and whenever we pass the native SQL query to add query annotation, we have to enable this attribute, that is native query equal to true. Okay, so whenever you pass native SQL query to add query annotation, make sure that you need to pass this native query equal to true. Okay, so this attribute will tell Spring Data JPA that we are passing native SQL query. Okay, so this is how you can use native SQL query to filter or search list of products by name or description. Okay, you can use either one, but I'm going to use this JPQL query. Okay, great. Now let's go ahead and let's develop the service layer. We'll go to the service package, right click on it, new, and then choose Java class, and then choose interface. Let's give interface name as product service and hit enter. And within this product service interface, we're going to define one method, and let's give method return type as list of type product, and let's give method name as search products. All right, and just pass string query as a method parameter. All right, perfect. So now we'll create a product service IMPL class that implements product service interface. Well, go to service package, right click on it, new, and then choose package. And let's give package name as IMPL. All right, within our IMPL package, we're going to create service class. Let's give service class name as product service IMPL. Okay, and this class implements product service interface. All right, perfect. Now let's go and let's override the methods from product service interface, and let's provide the implementation. All right, now once we create a service class, we have to annotate this service class with add service annotation from Spring Framework. All right, perfect. Next, we'll inject product repository interface in this class, and we'll call product repository methods. So let's go and let's define the product repository interface here. Product repository, and we're going to use constructor based dependency injection. So right click, generate constructor, and choose product repository and click OK. Okay, so here basically we are using constructor based dependency injection, and here we're not going to use add auto-add annotation because Spring Framework will automatically add auto-add annotation whenever it finds only one constructor for this class. All right, now we have only one constructor for this class, so we don't have to add auto-add annotation. All right, perfect. Now let's go and let's provide the implementation for this search products method. Well, here I'm going to get rid of this return statement, and here first we need to call product repository and its method, that is search products method, and I'm going to pass query as a parameter. Okay, so this search products will return a list of products, right? So let's have list of product, and let's call it as products, and let's go ahead and simply return these products. Okay, perfect. Now we have developed the service layer for this service products method. Next, we need to create a REST API. For that, we need to create a Spring MVC controller, right? So go to controller package, right click on it, new, and then choose Java class, and let's give class